Good evening, children.
Good evening.
Good evening, ma'am.
Good evening, ma'am.
Good evening, children. Good evening.
Good evening, ma'am.
Good evening. So children, you remember we had started quadratic equations? We had one session on quadratic equations.
Yes, ma'am.
Yes, ma'am.
Yeah. Just help me recollect, no? Where did we stop? Did we finish till here? Did we talk about the nature of the roots, the discriminant and all that? Please open your book, look into your book and let me know.
Ma'am, we wrote all that in our notebook, ma'am.
Okay, fine. All right. So let's just recall the last part regarding the nature of the roots of a quadratic equation. We'll just recall that. Okay, so we know that the standard form of a quadratic equation is ax squared plus bx plus c is equal to 0. And we also know that a quadratic equation has at most two roots. A quadratic equation has at most two roots. And the roots are called alpha and beta. The roots are alpha and beta. Now, I think we saw we understood the quadratic formula to find the roots of a quadratic equation. X is equal to minus b plus or minus root of b square minus 4ac by 2a, where this b square minus 4ac is called the discriminant. Discriminant. Because the value of b square minus 4ac, because it's under the square root, because the expression b square minus 4ac is under the square root, the value of this expression decides the nature of the roots of the equation. So if b square minus 4ac, the value is negative. If b square minus 4ac, if the value is negative, then square root of a negative value is imaginary. In which case the quadratic equation has no real roots because the roots are imaginary. The roots are complex. It has no real roots. Now, when the value of b square minus 4ac is 0, b square minus 4ac, if the value is 0, square root of 0 is 0. So this one becomes 0, this one becomes 0. So plus or minus 0. So it's nothing but x is equal to minus b by 2a. That means both the roots are minus b by 2a. This is the case when the quadratic equation will have two equal roots, one root or two equal roots. When discriminant is 0, when the value of b square minus 4ac is 0. If the value of b square minus 4ac is positive, then it will have two distinct roots. Somebody's mic is enabled. Please disable your mic. So this is the quadratic formula. Quadratic one, I'm writing again. So this is the quadratic formula. X is equal to minus b plus or minus root of b square minus 4ac divided by 2a. This is the quadratic formula. Now, what are these a, b, and c? This is the standard form of a quadratic equation. So you can see here, a is the coefficient of x squared, b is the coefficient of x, and c is the constant. So when you fill those values here in this formula, you will get the zeros of the two zeros, alpha and beta, of the quadratic equation. Now you can see this expression is under the square root. B square minus 4ac is under the square root. So the value of this expression, the value of b square minus 4ac decides the nature of the roots, of the quadratic equation, Why? Because that expression is under the square root. That is why b square, for this reason, b square minus 4ac is called the discriminant, because it decides the nature of the roots. That is why it's called the discriminant. For this reason, b square minus 4ac is called the discriminant, because it decides the nature of the roots of the equation. So case 1 is when b square minus 4ac, the value of b square minus 4ac is negative. That is, it's less than 0. Now this is called d. This one is called d. So you can b square minus 4ac, which is nothing but d. So when b square minus 4ac or d, when b square minus 4ac is less than 0, or in other words, d is less than 0. That is, it's negative. Less than 0 means negative. So square root of a negative value is not defined. It's imaginary. So when b square minus 4ac is less than 0, that is, if it is negative, the quadratic equation has no real roots. No real roots. Case 2, when b square minus 4ac is equal to 0, or in other words, d is equal to 0. So you can see here, square root of 0. So plus or minus 0 it will be. Plus or minus 0, that means there's only minus b by 2a. So that will be only one root. What about the other root? The other root is also minus b by 2a. So this is the case where the quadratic equation has real roots and real equal roots. Here the quadratic equation has real roots, real and equal roots. Both the roots will be equal to minus b by 2a. And case 3, when b square minus 4ac is greater than 0, or d is greater than 0. So you can see when it's greater than 0, supposing you have square root of 25, it can be a perfect square or an imperfect square. Can be anything. We'll just take a perfect square for convenience. Supposing b square minus 4ac is 25. So square root of 25, which is 5. So it will be, one value will be plus 5, minus b plus 5 by 2a, and the other value will be minus b minus 5 by 2a. So you will get two different values. So you will get one value for alpha, a different value for beta. Because if it is square root of 25, see, I told you it can be an imperfect square also. So supposing it is 25, square root of 25 is 5. So it will be plus or minus 5. So it will be minus b plus 5 by 2a. That is one value, alpha. And the other one, minus b minus 5 by 2a. A different value, no, minus 5 by 2a. That is beta. So here, the quadratic equation has real roots, but unequal roots. One root is called one root alpha. See, I'll just write it here. One root alpha is minus b plus root d by 2a, and the other root beta will be minus b minus root d by 2a. So real unequal roots. Equal roots are also called coincident roots. Unequal roots are also called distinct roots. We have already discussed all this, children, but since it's quite some time, I think this is a quick and effective recap, I hope. If you want to, I can give you, see, what I want you to do is just write it out again. If you have it already in your tuition notebook, you can just work it again in the rough notebook, just for practice. Write down this, children, all of you. All of you, please practice this. Write down and practice this one, children. I'll give you 5 minutes for this. Read the slide. First, read the slide. Understand any questions you ask me, and then you practice writing this. Children, just give me 2 minutes. Sashank is not able to join the meeting. I'll just help him 2 minutes. I think the meeting will go on hold. I don't know. Just please stay there. Take a screenshot of this one, children, so you can write this till I get back. Take a picture.
Taken, ma'am.
Okay, thank you. All right, children, I'm back. Recall. Are we ready to proceed, children?
Yes, ma'am.
Yes, ma'am.
Okay. All right. Anyone here has learned this chapter in school? Nobody?
No, ma'am.
Okay. All right. Look at this question. Now, today, what I'm going to do is, I don't think you'll be writing in today's class, children. It's 8 o'clock, and I'll teach as much as possible, and I'll share the pictures on what you can take screenshots. You can take screenshots. I think that will be better. You can take screenshots and complete it by the next class, children. Will you all do that?
Yes, ma'am.
Yeah, we'll just understand and
Yes, ma'am.
explain, as much as possible so that we can complete a good amount, though we started the session late. Please complete it by the next class on Saturday. All right. Thank you, children. Look at this question. Prove that x square into a square plus b square plus 2x into ac plus bd plus c square plus d square is equal to 0 has no real root if AD is not equal to BC. Okay. Now we need to first understand what is given. Write the equation like this so that we understand. See here? So this is the x square term. This is the x square term. And this is the coefficient of x square. This is the x term. And this is the coefficient of the x term. And this is the constant. This is the constant. See, you can see that this equation has three terms. This is the x square term. It is given as x square into a square plus b square. You write it like this, a square plus b square into x square. So see, like 5x square, a square plus b square of x square. So this is the x square term. This is the x square term. And here we have 2x into ac plus bd. So we'll write it like this. You see, we still have 2x here. We have 2 here, x here, 2x ac plus bd. So this is the x term, where the coefficient of x is this one. This is the coefficient of x. What is the coefficient of x square? This is the coefficient of x square. And the constant is the one which does not have an x square or an x term in it. The constant is the one that does not have an x square or an x in it. So you can see here, c square plus d square. There is no x or x square. So this is the constant. So x square, the coefficient of x square is a square plus b square. Then x term, the coefficient of x term is 2 into ac plus bd. And the constant is c square plus d square. So that is, this is a. What's the standard form? Ax square plus bx plus c is equal to 0. This is the standard form. A is the coefficient of x square. B is the coefficient of x. C is the constant, is equal to 0. But here we already have those letters A, B, C. So in order to differentiate, we'll call this capital A. The coefficient of x square with capital A. The coefficient of x, this one, is capital B. And this one, the constant, is capital C. Because if we use A, B, C, we already have those letters used in the equation given. So it will be confusing. You should not do that. So let's differentiate using capital letters. Capital A, capital B, capital C. Assuming that the standard form is ax square plus bx plus c is equal to 0. If this is the standard form, assuming that this is the standard form, capital Ax square plus capital bx plus capital c is equal to 0. Is it fine, children, so far? Yes or no?
Yes, ma'am.
Okay.
Yes, ma'am.
I'll let you know. So now see here. Now, what is given here? That the quadratic equation has no real root. You'll have to prove that the quadratic equation has no real root. You have to prove that this equation has no real roots if this condition is given, AD is not equal to BC. We have given a quadratic equation. Now we understood this equation. We understood the what the x square term is, the x term, and the constant is, the expressions for A, B, C, all that we understood. Now what you have to do is you'll have to prove that this quadratic equation has no real roots if AD is not equal to BC. If AD is not equal to BC. So see here. So to show that it has no real roots, you will have to find the discriminant. You will have to find the discriminant. So how will you say using the discriminant? If the value of the discriminant is less than 0, if the value of the discriminant is less than 0, if the value of the discriminant is less than 0, then you will say that the quadratic equation has no real roots. If the value of the discriminant is less than 0, because that's what we understood. If the value of d is less than 0, the quadratic equation has no real roots. If the value of d is equal to 0, the quadratic equation has real equal roots. And if the value of d is greater than 0, the quadratic equation has real unequal roots. Okay. So to prove that it has no real roots, we'll have to show that d is less than 0. D is less than 0. Okay, that means we'll have to find the d. We'll have to find d. What is the value of d? You must show that the value of d is negative. You must show that the value of d is negative. Since the value of d is negative, the quadratic equation has no real roots. Since the value of d is negative, the quadratic equation has no real roots. So we are going to find d. We are going to find the d. Okay. So find d using the expression b square minus 4ac. See here. So you can see here, I told you this A, B, and C. A, this is A. Take away this X. Take away this X. This is B. How do you find A, B, C? Take away the X square. This is A. This is A. This one is A. Take away the X. This is B. And this is the constant C. If you remove the X square, whatever is remaining is A. If you remove the X, whatever is remaining is B. And this is the constant. So that's what I've written here, A, B, C. Now we are going to find the D. D is B square minus 4AC. So first substitute. Substitute. So see here, this is B. What is B? This is B. This is B. So you can see a B square minus 4 into A into C. A into C. 4 into A into C. So now square this. What is 2 square? 4. And then AC plus BD, the whole square. The square is for 2 and this expression. The square is for 2 and this expression. So 2 square is 4 and this one is AC plus BD, the whole square. Minus 4, and you know how to multiply this. A square into the second bracket, B square into the second bracket. Okay, so it will be A square C square, A square D square, B square C square, B square D square. Now you can take out 4 common. 4 is common. See here, between this one and this one, 4 is common. So I've taken out 4 common. I've taken 4 common. And what will happen to this when you expand this? A square plus B square plus 2AB. Or you can say that it looks like X plus Y the whole square. X plus Y the whole square. So X square plus Y square plus 2XY. X square plus Y square plus 2XY. X square. Y square. 2 into X into Y. So 2 into AC into BD. So 2ABCD. And then we've taken out this minus, 4 common, right? So it will be minus A square C square, minus A square D square, minus B square C square, minus b square d square. So when you take out 4 common, first we expand this. See, we need to write this inside the bracket. Instead of writing this, we expand it and write it. Then the 4 is common here. So with the minus sign, the minus will be applied to every term inside the bracket. So all of them become negative. Then on simplifying, like terms are there. You please find the like terms. And when you simplify, see, you can see here, a square, c square, they get cancelled. b square, d square gets cancelled. Minus a square, d square, plus 2a, b, c, d, minus b square, c square. So of the 7 terms, 4 terms get cancelled. There are 7 terms in the bracket. 4 terms get cancelled. So you're left with 3 terms. You're left with 3 terms. Now take a minus outside because you can make this look like x plus y the whole square or x minus y the whole square. Take out this minus, take out this minus common. See here, this one, this minus. So it'll become minus 4. You can see here. 4 has become minus 4 here. 4 has become minus 4 here. So taking out a minus sign. So this will become a square d square. And this will become plus will become minus 2a b c d. And this becomes plus b square c square. Why? Because we've taken a minus outside. Minus 4 into a square d square. Minus into minus plus. Minus into minus plus. You can see this plus. And minus into plus minus. You understand now when you take out a minus common, you'll have to change the signs for all the terms inside the bracket. When you take out a minus common, you'll have to change the sign for every term inside the bracket. This negative term will become positive. Positive will become negative. Negative will become positive because you've taken out a minus sign. Now you must show that this is of the form x minus y the whole square. So see, write this as AD the whole square. This one is BC the whole square. And this can be written as 2 into AD into BC. The middle term can be written as 2 into AD into BC. 2 into AD into BC. So clearly this is of the form x the whole square plus y the whole square minus 2 into x into y. It's of the form x the whole square plus y the whole square minus 2 into x into y. Correct? So it's nothing but x minus y the whole square. It's nothing but x minus y the whole square. X minus y the whole square. So AD minus BC the whole square. Now what is given to us? AD is not equal to BC. That if two quantities are not equal, their difference cannot be 0. If two quantities are equal, say two quantities are equal, that means their difference will be 0. If two quantities are not equal, their difference will not be 0. Their difference can be either positive or negative, depending on how you subtract them. See here, now two quantities are equal, 5, 5. So their difference will be 0. Now these are two quantities which are not equal. What will be their difference? If you subtract like this, their difference will be minus 2. If you subtract like this, their difference is a positive 2. So it depends on the order in which you subtract them. When two things are equal, their difference is 0. When two things are not equal, their difference will be positive or negative, depending on in which order you subtract them. So it's very clear that since AD is not equal to BC, it's very clear that their difference is not 0. Since it's given that AD is not equal to BC, these two quantities are not equal. That means their difference, it will not be 0 because they're not equal. So their difference will not be 0. So if their difference is not 0, when you square the difference, their difference is not 0. If you square the difference, what will that be? The square of the difference, that also cannot be 0, right? Because the difference itself is not 0, then how will the square be 0? So if the difference is not 0, that the difference square also will not be 0. Then what will be the value of this one? It can be positive or negative, but it cannot be negative because whenever you square something, it will always be positive. Whether inside this value can be negative, but when you square it, it will become positive. So whether this difference is -3 or +3, when you square it, it becomes a +9 only. So that means the difference square will be positive. That means greater than 0. See, what we understand in words is written symbolically. That's all. You must use the signs. To say it is negative, you must say less than 0. To say it's positive, you must say greater than 0 or equal to 0 if it is equal to 0. If it is less than 0, you must, if it is negative, you must say less than 0. If it's positive, you must say greater than 0 or equal to 0. See, it's very simple. The two things are not equal. That means their difference is not 0. If the difference is not 0, if AD minus BC is not 0, then when you square it also, the answer will not be 0. Then what will be the answer? If it is not 0, what can be the answer? It will be either positive or negative because it's not 0. That means it should be less than 0 or more than 0. It will be negative or positive. But it cannot be negative because it's something squared. When you square it, it cannot be negative. It has to be positive. That means AD minus BC the whole square is positive. That means greater than 0. Now, this one is positive. What is positive? This AD minus BC the whole square. This one is positive. This one is positive. When you multiply this with a -4, the product will be negative because minus into plus is minus. This is a -4. There's a minus sign here. Now, this one we understood is a positive value. Whatever be the value, it is positive. It has a plus sign. Now, forget this number 4. This is negative. There's a minus sign here. Now, here, whatever value we get, it will be positive. Now, plus into minus is minus. That means the discriminant is negative. That's what I've written here. This one is greater than 0. This is positive. When you multiply that positive value with -4, the product will be negative. That means it will become less than 0. Now, don't learn this like this. Don't think if you put greater than 0 in the first step, then in the next step, you should write less than 0. It's not like that. It's not like that. This one is positive, so greater than 0. This positive value multiplied by -4 will be negative. So less than 0. Less than 0 meaning negative. That means the discriminant is negative. Because what is -4 into AD minus BC the whole square? It's nothing but the discriminant, right? So we have proved that it is negative. D is negative. D is less than 0. That means it has no real roots. You don't have to find the value of D. What is the value of D? That you cannot find because it's all A, B, C, D here. But whatever be the value, it is negative. So if it is negative, the quadratic equation has no real roots. See, so we got D is equal to -4 into AD minus BC the whole square. This is what we got. Okay, now you have to prove that this is negative. You have to prove that this expression is negative. We got the value of D. D is -4 into AD minus BC the whole square. Now you have to prove that this is negative. Only if you show that, only when you prove that this is negative, D is negative. So if D is negative, the given quadratic equation has no real roots. So how do we show that this is negative? So we take the parts of it. What are the two parts of this expression? -4 and AD minus BC the whole square. These are the two parts. So we're going to analyze this AD. First, we'll start from here, AD minus BC. What can be the value of AD minus BC? It cannot be 0. Because they are not equal. AD and BC, they're not equal. So their difference, AD and BC, their difference will be negative or positive. So when you square it, then the value will be positive. So this one is positive, that is greater than 0. Now, when this positive value is multiplied by -4, then this whole thing is negative now. Because this is positive. You're multiplying that with a -4. This whole thing is now negative. That means D is negative. D is negative. If D is negative, that means a quadratic equation. Because D is the discriminant. And the value of B squared minus 4AC decides the nature of the roots of the equation. And you have proved that D is negative. If D is negative, that means that B squared minus 4AC, it's negative. That is only under the square root. No, it's negative. That means the quadratic equation has no real roots. No real roots. Take a screenshot, children.
Taken, ma'am.
Yeah. See, remember, this is how you get the values of A, B, and C. Without the x squared, this one is A. Without the x, this is B. And this is C. Yeah. So here again, we have this quadratic equation, B minus C of x squared plus C minus A of x plus A minus B is equal to 0. Okay, so we are given a quadratic equation, and what's given? The roots are equal. Is given. It is given that this quadratic equation has equal roots. It is given that this quadratic equation has equal roots. When can it have equal roots? Only when the value of D is 0. When D is 0. D is 0 means equal roots, real equal roots. When does the quadratic equation have equal roots? When D is 0. So that means here we have a condition already. D is equal to 0. This is enough for us. In mathematics, when you're given, it's like in English, you know, given a topic, maybe you can talk so much about it. Okay. So like that here in mathematics, when you have an equation, that's enough. You can just work with that, solve that, and, answer whatever you have to. So this is enough. This condition is enough. I'll tell you again. We are given a quadratic equation. Okay. Again, what is the value of A? Remove this. This is A. This is B. And this is a constant C. Again, we're using capital ABC because we already have small letters A, B, C in the quadratic equation already. So to differentiate, we'll use capital A, B, C. And what is given? Roots are equal. It's given. Roots are equal. When will the quadratic equation have equal roots? When D is 0. So that means D is 0 here. That's why it's given the equation, the roots are equal. So we already know the condition here. D is equal to 0. A is B minus C. B is C minus A. All right. So we know that D is equal to 0. D is equal to 0 because roots are equal. That means B square minus 4AC is equal to 0. B square, because D is B square minus 4AC. Both are the same. See, like, you remember when you were young, you would have written area of rectangle. Area of area of rectangle is equal to 40 meters square. L into B is equal to 40 because area of rectangle is L into B, right? Area of rectangle is L into B. So L into B is equal to 40. Then maybe you're given B. So L into 15 is equal to 40, like that. Excuse me, children. Yeah, children. So I was telling you that so if you're given area of rectangle is 40, so under area of rectangle, you will write L into B because area is L into B. Similarly here, D is equal to 0. That means B square minus 4AC is equal to 0. Now substitute the values. What is B? C minus A the whole square. 4 into A, B minus C. And C is A minus B. A is equal to 0. So you just have to work this and prove that 2B is equal to A plus C. All right. Let's see the answer. So see here. So D is equal to 0. B square minus 4AC is equal to 0. I've substituted here. Then, of course, you'll have to expand. What is C minus A the whole square? C square plus A square minus 2AC. And here you'll have to multiply B into A, AB. B into B, B square. C into A, AC, and then BC. You know how to multiply the signs also. All right. So here you'll have to expand this. And here you multiply B minus C into A minus B. You get these terms. Now multiply 4 with all the terms inside the bracket. Multiply 4 with all the terms inside the bracket. So it will be minus 4AB plus 4B square plus 4AC minus 4BC is equal to 0. Is equal to 0. So that's simple, no? D is equal to 0 because roots are equal. So the condition is D is equal to 0. B square minus 4AC is equal to 0. Substitute the values. So expand this one. Multiply here. Yeah. So now just see if you have any like terms. Yeah, AC and AC here. We have AC and AC here. Plus 4AC and minus 2AC. Plus 4AC and minus 2AC. So that will become plus 2AC. So you can see here plus 2AC. And also I've arranged the terms in a particular order. What is it? Write A square first. Then write this 4B square. Then write the C square. Then write the AB term minus 4AB. Then write the BC term minus 4BC. Then write the AC term plus 2AC. How plus 2AC? Because this one and this one simplifies to plus 2AC. So we are writing it in that order. First the A square term, then the B square term, then the C square term, then the AB term, the BC term, and the AC term. Now recall this identity from 9th standard. So show that whenever we have 6 terms like this, whenever we have 6 terms, x square, y square, z square, 2xy, 2yz, 2xz, this can be factorized as x plus y plus z the whole square. So this one is, see here, we have 6 terms here. A square, B, we have A square, B square, C square term, AB, BC, CA, like x square, y square, z square, xy, yz, zx. So like that. So show that it's in that form. This write this as AB, A the whole square. This one will be, I'll tell you how we get the minus sign. I'll tell you how we get the minus sign. This is 2B the whole square. This is C the whole square. Now you can see that these two terms are negative. These two terms are negative. So 9th standard, we have learned that when you use this identity, when these two terms, these two terms are negative, they have B in common. The two terms have B in common, B in common. That means fix a minus sign to the B term. Fix a minus sign to the B term. See here, minus, these two terms are negative and they have B in common. So you come here to this B term. So that is to this one, fix a minus sign in the bracket. Inside the bracket. B is common. For the two negative terms, B is common. So you come here to this B term. In the bracket, you fix a minus sign. However, when you square it, minus 2B into minus 2B is plus 4B square only. Minus 2B into minus 2B is plus 4B square. Okay, so plus C square. Then write this as 2 into X into Y. Children, I think I'll do this here for you because 1 minute. A square 4B square plus C square. minus 4ab minus 4ac is 2ac. Okay. So the first thing is these two terms are negative. So to this b term, you should fix a negative term sign. Right? This is a the whole square plus b negative whole square. Now square this one. 2 minus 2 into minus 2 is plus 4 b square plus c the whole square. Now you've got x, y, z. What is x? A. What is y? Minus 2b. What is z? C. X is a because x square it is. This is x square. This is y square. This is z square. So x is a, y is minus 2b, and z is c. Now we will have to write plus 2xy plus 2xy. So it will be plus 2 into x, which is a, into y, which is minus 2b. Now the identity says plus 2yz. 2xy, 2yz. So 2 into y. What is y? Minus 2b. Into z. Again plus 2 into c. Into a. After identifying the x, y, and z terms, how do you write 2xy, 2 into x into y, plus 2yz, 2 into y into z, this one. And then 2 into x into z, 2 into x into z. So when you do that, and see and check, see here, 2 into x into y, 2 into x into y. What is this? Minus 4ab. That's what you have here. Multiply this 2 into y into z, 2 into y into z, because y is minus 2b, z is c. Multiply this minus 4bc. That's what we have here. And multiply this minus 2c. So what we are doing is we are trying to show that this expression is perfectly of the form x squared plus y squared plus z squared plus 2xy plus 2yz plus 2xz. You can, though you write it in a different way, their products, they match. You get the same terms as above here. So clearly this expression is of the form x squared plus y squared plus z squared plus 2xy plus 2yz plus 2xz, where x is a, y is minus 2b, and z is c. So what's the answer? X plus y plus z the whole square. X a plus y, but it's minus 2b, no? So plus minus 2b, so minus 2b. Plus z the whole square plus c the whole square is equal to 0. Why is equal to 0? Because we are working with the condition d is equal to 0. So that equal to 0 is here, equal to 0. So equal to 0. So if the whole square is equal to 0, that means a minus 2b plus c is equal to 0. That means a plus c is equal to 2b. Transposing. A plus c is equal to 2b. Transposing, you get a plus c is equal to 2b, or 2b is equal to a plus c. Hence, sorry. Yeah. Tell me, children. Understood this identity part because this is of 9th standard? So here we have a quadratic equation. We are given that the roots are equal. If roots are equal, that means the value of d is 0. That means b squared minus 4ac is 0. Substitute the values of a, b, c and simplify. So you get something like this. This is perfectly of this form, So this can be factorized as x plus y plus z the whole square, where x is a plus y plus minus 2b, so minus 2b, plus z plus c, the whole square, is equal to 0. So whole square is equal to 0. That means a minus 2b plus c is also 0. On transposing, a plus c is equal to 2b, or 2b is equal to a plus c. Any questions, children? Please ask me if you have any doubts. All right.
Ma'am, could you please show the previous slide? I need to
Oh,
take
yeah.
a screenshot.
Yeah. Children, yeah, please take a screenshot. I forgot to say that. Please take a picture. Oh, 1 minute, 1 minute. I think it's right. Yeah. Done, children?
Yes, ma'am.
Yes, ma'am.
All right. So now that you've understood the values of A, B, and C, I think we can go a little faster. So take out this is A, this is A. Take out this X, this is B, and this is C. Okay, so what is given here? What is given here? We are given a quadratic equation, and it's given that the roots are equal. If the roots are equal, that means D is equal to 0. Given this, you should prove that A by B is equal to C by D. Okay, so D is equal to 0. B square minus 4AC is equal to 0. Substitute B. This is B. I told you, no, without the X is B. So this is B. Substitute B. This is B square minus 4 into A into C. A into C is equal to 0. Expand this one. Expand this. So minus 2. Expand this. Minus 2 squared. Minus 2 squared is 4. And AC plus BD the whole square, because the square is for both minus 2 and this one. And here again, you'll have to multiply. Multiply like this is equal to 0. Now you can see that I'll tell you the difference between this sum, the first one. In the first one, children, it's an expression. We are finding D. See, I'll tell you. Well, I'll give you a different example. Once again. Okay, so children, see, yeah, please get this difference. Suppose you're finding the area. Supposing, okay, you're finding the area, and you have something like 4 x square minus 4 y square. Can you divide by 4 here, children? Can you divide by 4 as against this one? Supposing you have 4x square minus 4y square is equal to 8. Now, what I'm saying is here, this is an expression. It's not an equation because you're finding area. Area is equal to area is given by this expression. This is not an equation. Area is equal to this expression. You cannot divide by 4 throughout. If you're dividing by 4 throughout, you should divide area by 4, this one by 4, and this one by 4. So in a case like this, where you have area is equal to 4x square minus 4y square, actually this is an expression. So you can only take out 4 common. 4 into x square minus y square like this. But here this is an equation. So you can divide by 4 throughout. You can divide by 4 throughout, and you can write the equation as this one. When it is an expression, you can only take out the common factor. You cannot divide by the common factor. When it's an equation, you can divide both the sides by the common factor. So that's what we see here. See here, we did not divide by 4 throughout. See here, we only took out 4 common. We kept 4 common. Because this one has 4, you cannot divide this one and this one by 4 because it's an expression. You're finding D. It's an expression. This one is an expression. So you can only take out 4 common. You cannot divide by 4. Unlike this situation, we have an equation. D is equal to 0. We started only with an equation. D is equal to 0 is an equation. So here you can divide by 4 throughout because here there's 4. Here also there's 4. So you can divide by 4 throughout. So you can see how it looks like when you divide by 4 throughout. It looks like this. So 4 and 4 gets cancelled. This 4 and 4 gets cancelled. And 0 by 4 is 0. 0 by 4 is 0. Then this minus sign, you can see the minus sign here. Apply the minus sign to every term inside the bracket. Minus a square c square, minus a square d square, minus b square c square, minus b square d square is equal to 0. Then again, there are 7 terms. What happens? This one and this one gets cancelled. This one and this one gets cancelled. And you're left with this one, and this one is equal to 0. Then we change the signs throughout. Because see children, why do we change the sign throughout? Supposing you have minus x square. Okay, supposing you have minus x square plus 2xy minus y square is equal to 0. Okay, supposing you have this, what will you do? We'll change the signs throughout. You'll write minus x square as plus x square, plus 2xy as minus 2xy, minus x square as plus y, minus y square as plus y square is equal to 0, so that you can write it as x minus y the whole square is equal to 0. Changing the signs throughout. Why did we do that? Because here we had minus x square plus 2xy minus y square. When you change the signs throughout, using the identity, you can write that as x minus y the whole square. Similarly here, the middle term, see here, these 2 terms are negative. This one and this one are negative. Only if you have them positive, you can show that it is of the form x plus y the whole square or x minus y the whole square. So change the signs throughout. Minus becomes plus, plus becomes minus, minus becomes plus is equal to 0. Now that's nothing but this one can be written as AD the whole square, BC the whole square. So the middle term 2 into AD into BC, 2 into AD into BC is equal to 0. So now this is of the form x square minus 2 into x into y. X square minus 2 into x into y plus y square, which is nothing but x minus y the whole square. X minus y the whole square, which is nothing but x minus y the whole square. AD minus BC the whole square is equal to 0, which means AD is minus BC is equal to 0. On transposing, AD is equal to BC. Now see how you want the result. How do you want the result? You want the result like A by B is equal to C by D. You want A by B. So bring the B for division. Bring this B for division because you want A by B. So bring this B for division. So AD by B is equal to C. Then take this D for division to the other side. This D for division to the other side. So you get A by B is equal to C by D. Hence proved. A by B is equal to C by D. Yeah, take a picture, children. Sorry. Please take a picture.
Done, ma'am.
Yeah.
Taken, ma'am.
Okay. Very good. Yeah. Now this, you tell me, we'll work this together. Anybody, it's an open question. Children, just go through this. Maybe if you have any questions, you can ask me. Anyone wants to ask any question now?
No doubts, ma'am.
Yeah. So here also the roots are given to be equal, children. Here also the roots are given to be equal. So D is equal to 0. Now it's an open question. Tell me what is A?
B square minus AB, ma'am.
Very good. What is B?
A square minus BC, ma'am.
No.
Minus 2A square minus BC.
Yeah, minus 2 into A square minus BC. Then what is C?
B square minus AC.
Yes.
B square minus AC. A is equal to, this is A, C square minus AB. This is B, minus 2 into A square minus BC. And the rest of it, the rest of it is C, B square minus AC. All right. So now we know, or we are given that the roots are equal. So that means discriminant is equal to 0. Roots are equal only when D is equal to 0. That means B square minus 4AC is equal to 0. So B square, I'll substitute that. This is B. Here, children, this is B square. Right, B. This is B. Minus 2 into A square minus BC is B. B square minus 4 into A into C is equal to 0. Yeah. Now from here you help me. Yes, Prajit. Yeah, tell me. Square it. Minus 2 squared is?
Plus 4.
4. Then A square minus BC the whole square. Because
Yes.
the square is for both of it, no? So
Yes.
minus 2 squared is 4 and A square minus BC the whole square. Then minus 4 into multiply.
C square, B square.
Let's write B first. So B square, C square, then
AC square minus AC square.
minus AC
Cube.
cubed.
Minus AB cube. Minus A square plus A square BC.
Is equal to 0. Next, is this an equation or an expression, children?
Equation, ma'am.
Equation.
So can we divide by 4 throughout?
Yes,
Yes.
ma'am.
We can divide by 4 throughout. So we'll divide by 4 throughout because 4 is common. We'll divide by 4 throughout. So 4 and 4 gets cancelled. 0 by 4 is 0. Now expand this one. Expand this. Expand
A
this one.
square, the whole square.
So that will be a to the power 4. Yeah, you're right. Next.
Plus B square C square.
Plus B square C square.
Ma'am, minus 2a square BC.
Minus 2a square BC. Very good. So it's of the form x minus y the whole square. A square minus BC, the whole square is of the form x minus y the whole square. So how do you expand this? X square plus y square minus 2xy. Or you can write x square minus 2xy plus y square. Both are fine. Both are fine. X square plus y square minus 2xy or x square minus 2xy plus y square. Both are fine.
Yes, ma'am.
Yeah. Continue. Now see your children, this minus sign. This minus has to be applied with every term inside the bracket. So apply it. Minus
B square C square.
B square, C square,
Plus
plus
C cube.
A C cube.
Plus AB cube. Minus A square BC.
is equal to 0. Now, like terms, tell me if something can be simplified.
And
No
B square
hurry.
C square.
Just watch. Yeah.
B square, C square.
It's cancelled. Okay. Then
Minus 2A square BC minus A square BC gets minus 3A square BC.
correct. This becomes minus 3a square BC. Correct. Then anything else we have?
No, ma'am.
No, ma'am.
No. Okay, fine. So now we'll write a to the power 4 first. Then we'll write this one, which has B, then C. We'll write this one then. Then we'll write this one, which has C. Then this simplified one, minus 2a square BC minus a square BC is minus 3a square BC is equal to 0. I think we have not missed anything. A to the power 4. Then I said we'll write this B, AB cubed, then the C, AC cubed, and these two we put it together. Yeah, minus 3a square BC. Next what, children? Observe the terms and tell me next what?
Transpose that minus 3a square BC to the other side.
Okay, very good. Transpose. Okay. Because that's how the result looks like. Look at the result. Okay, but you're right.
Therefore, then we have to divide by a, ma'am, all through.
Yeah. Very good. That's what I wanted. So before you transpose, you can either take out a common or you can divide by a throughout. No, common meaning after taking common, it will go for division to the other side. See like this, a into a cubed plus b cubed plus c cubed minus 3. Minus 3 what, children?
ABC.
ABC is equal to 0. Then in the next step, the 0 will come here, no? 0 by a. So it will become 0, right?
Yes, ma'am.
It will become 0 now. I'll take out this also. See, there is a here. We took out a common, and we get a cube plus b cube plus c cube minus 3abc is equal to 0. There is a. No, but we have to prove that. Okay, sorry. We have to prove that a is equal to 0 or we'll have to prove that a is equal to 0 or 1 second. A is equal to 0 or A cube plus B cube plus C cube is equal to 3ABC. So then what you have to do is the product is 0. The product is 0. When the product is 0, see, like when you have x minus 4 into x minus 3 is equal to 0, what do you say? X minus 4, either x minus 4 is 0 or x minus 3 is 0. So x is equal to 4 or x is equal to 3. Similarly, here the product is 0. The product is 0. That means either A is equal to 0 or the A cube plus B cube plus C cube minus 3ABC is equal to 0. So now here when you transpose this to the other side, you will get therefore A cube plus B cube plus C cube is equal to 3ABC. So we have proved that either A is equal to 0 or A cube plus B cube plus C cube is equal to 3ABC. So it is very, very simple, children. The question may look like that, may look scary. But it's very, very simple. You just have to write this D is equal to 0. B square minus 4AC is equal to 0. Substitute the expressions and simplify. Yeah, have a look at the answer, children. Step by step, please go through and take a screenshot also. I'll just come back, children. Please go through this answer. Okay, over to the next one, children. Yeah. This also we'll do it together. Tell me.
A is equal to 1 plus m square.
Okay.
Two MC, ma'am.
C square minus A square.
Very good. Yeah. So these are three terms. This is the first term. This is the second term. This is the third term. You can see the separator plus, plus. So this is the first term. Take out this x square. So this is A. Second term. Take out the x. This is B. And this entire thing is C. So we identified the values of or the expressions for A, B, and C. Next, since it's given that the roots are equal. The roots are equal is given. If the equation has equal roots, that means D is equal to 0. That means B square minus 4AC is equal to 0. So substitute 1 plus M, the whole, oh sorry.
2MC the whole square.
2MC whole square.
Yeah. 2MC, the whole square, minus 4 into A into C is equal to 0. Yeah, continue from here.
4
M
m
square
square
is
C square
minus 4.
minus 4
1
C
plus
square minus A square.
So 1 into C square is C square. 1 into minus A square is minus A square. M square into C square is
C
plus C square M square and minus A square M square. Okay, after this,
divide by 4.
Divide by
divide.
4.
Very good. Divide by 4. Because it's an equation, you can divide by 4. And this becomes 0. So you have C square M square. We'll write it in the alphabetical order, okay? Like we'll not write. I'll tell you the importance of writing it in the alphabetical order. Because sometimes, you know, you will have 4 M square C square, and maybe you have minus 4 C square M square. But suddenly, you know, you might not realize that they are the same and you will not cancel it out. Suddenly, you might feel like they're different because this is M square C square, this is C square M square. They are the same. So to avoid this mistake, you can always write it in the alphabetical order. So don't write M square C square, write as C square M square. A, B, C, then M. So C square M square minus C square multiplied by
Plus A square
A square minus C square M square.
plus A square M square.
is equal to
A
0.
square M square minus C square M square gets cancelled.
Okay. Now look at the result. We have C square on one side. So shall we write A square plus A square M square is equal to C square? We have 3 terms left. 1, 2, 3. We have only 3 terms left. If you look at the result, we have C square alone on one side. So we'll take C square because it's minus C square. No, so we'll transpose it. It'll become plus C square. Then there's A square plus A square M square as it is in the left hand side. Now what next?
A square is common, ma'am. We should take A
Yeah,
square.
A square common. Very good. That's it. We got the result. Look at the result to be proved above. C square is equal to A square into 1 plus M square. We got that. C square is equal to A square into 1 plus M square. So in all these questions, children, we were given a quadratic equation. In all these questions we saw so far, we were given a quadratic equation. And for the quadratic equation, it's given that the roots are equal. The roots are equal. The equation has roots and the roots are equal. So when are the roots equal? Only when d is equal to 0. So we take the condition d is equal to 0. In other words, b square minus 4ac is equal to 0. We substitute the expressions for a, b, c, and it's just algebra after that. There's no quadratic equation from here. Just tell me here what part of this is quadratic equation. Meaning of 10th standard, I'm saying. Nothing. Of 10th standard, it's just picking out the values of a, b, c. It's writing d is equal to 0 and b square minus 4ac is equal to 0. That's all. Only this is 10th standard. In this answer, I'm saying, in this answer, only the first three steps 10th standard. Then after the substituting, squaring it, taking out common, nothing. And this got nothing. This is just algebra. It's got nothing to do with the concept in, the concepts in this chapter of quadratic equations. Nothing, no idea. Now, if you give this to an 8th standard student, even that student can solve this. Because they know how to multiply a binomial with a binomial. So little help you have to give them, like you should say divide by 4 throughout and all that. The rest they will do it. So it is that easy, and this will be for 3 or 4 marks. Read the question. Very important is to read the question a few times and familiarize the question. When you see this question in the exam, you should realize, oh yeah, this one, that's very simple. You must read the question. You must, so important should be whenever the question is like of this sort, where it's completely new, like it's not numerical. Everything is new about this. The way the quadratic equation looks itself is new. The way the quadratic equation looks itself is new. 1 plus m square of x square plus 2 mcx, it's kind of not friendly. So understand that we may be given a quadratic equation like this with the condition that it has equal roots. And then we'll be asked to prove some result like this. So for that, we should carefully find out the expressions for a, b, c from this. Then because roots are equal, you should write d is equal to 0, b square minus 4ac is equal to 0. Then substitute and work. That's all. It's very, very simple. Read the question and familiarize the question. Yes, children, take a picture. Done, children? Okay. No, most of it are deleted for you. So I'm just checking on the ones which you have. Okay, let's do something different now. Okay. Look at this question, children. Find the value of k for which the equation, the quadratic equation, has equal roots. Again, here it's given it has equal roots, but you should find the value of k. So far, we were given a quadratic equation. We were also given that it has equal roots, but we had to prove some other result. In the questions we saw so far, we were given a quadratic equation with equal roots, but we had to prove some result, prove that c square is equal to a square into 1 plus m square. We had to prove something. But here we have to find the value of k. Quadratic equation, equal roots, for which the equation has equal roots. The equation has equal roots is given to you. Find k. Find k. Do this. Do this, children. I'll just help you to. You should start like this. That's all. Do this. Happening, children? Able to do it right?
Yes, ma'am.
Yeah. close, children?
I'm getting two values for k.
Yeah, what are the two values?
14 and 12.
14 and
12.
12. Looks right. Very good. What's the quadratic equation you got?
K square minus 26 k plus 168.
Okay, your answer is right. Maybe you didn't take out the common factor, or you didn't divide by 4 throughout. That's fine. That's fine. Anyways, your answer is right. 14, 12. Very good.
Ma'am, I got 6 and minus 7.
Okay, let's see. Yeah. So children, here see, you can use small a, b, c because you don't have those letters in the equation here. See, we don't have those letters a, b, c in the equation here. So you can normally use a, b, and c. Small a, small b, and small c. So what is the expression for small a? K minus 12. Small b, take out the x. So 2 into k minus 12. And c, 2. Equal root. So d is equal to 0. That means b square minus 4ac is equal to 0. Substitute b square 4ac. Then this is 2 square 4. 4 into k minus 12 the whole square. 4 2s are 8 into k minus 12 is 0. So at this point, you should divide by 4 throughout to simplify the equation. So divide by 4 throughout. So when you divide by 4 throughout, 0 by 4 is 0. So we have k minus 12 the whole square minus, you have 2 here, don't forget, 2. 2 into k minus 12 is equal to 0. So see, you can either expand this, children. Even if you expand this, you will get it. I have taken out k minus 12 common. I'll also expand it and show you. I have taken out k minus 12 common. So when you take out k minus 12 common, you will get k minus 12 here, minus 2. K minus 12, because k minus 12 into k minus 12 is k minus 12 the whole square. Minus 2 into k minus 12 is equal to 0. All right. Okay, so k minus 12, this minus 12 minus 2 is minus 14 is equal to 0. So k minus 12 is 0 or k minus 14 is 0. So k is equal to 12 or k is equal to 14. If we expand this, children, you'll get k square minus 24k plus 144 minus 2k plus 24 is equal to 0. So you have a quadratic equation like this. K square minus 26k, exactly what Prajit said, plus 168 is equal to 0. Yeah. So here we have to spend a little more time in figuring out the numbers with which you can split the middle term. It's fine. It's not wrong. You know, you're not wrong. So split the middle term and you will get the same two factors. You can also do it like this. So I have taken out k minus 12 common. K minus 12 common and then worked it. So we have k minus 12 into k minus 14 is equal to 0. So k is equal to 12 or k is equal to 14. Is this fine, children?
Yes, ma'am.
Yes, ma'am.
Very good. Good, Prajit. Well tried.
Thank you, ma'am.
Take a screenshot, children. I'll give you another one like this. With that, we'll wind up the session for today. We'll do another one like this and wind up the session for today. Take a screenshot. Yeah. Okay, you can do this, children, because the meaning is the same. See, for what value of k, the equation given there is a perfect square. See, if a quadratic equation is a perfect square, then the value of d will be 0. We'll see that now. Let's take a perfect square as an example. Let's take an example of a perfect square. Now, supposing you're like, how do you know that, an equation is a perfect square? You can just do this. Randomly write something like this. Expand this, children. So you'll get 4x square minus 1020x plus 25. Correct. So now you know that this is a perfect square because you have squared 2x minus 5. So 4x square minus 20x plus 25 is equal to 0 is a quadratic equation which is a perfect square. See, how do you know it's a perfect square? Because it is 2x minus 5 the whole square. It's 2x minus 5 the whole square. So 4x square minus 20x plus 25 is equal to 0 is a quadratic equation which is a perfect square. Now let's find d, children, for this. Let's find d. I'm not answering this question now. We're trying to understand what the value of d would be for a quadratic equation which is a perfect square. What is d? B square minus 4ac. So b square, this is a, this is b, this is c. B square, so it will be minus 20 the whole square. Minus 4 into a into c. Multiply this, we'll get 400, 0. You try this for any quadratic equation, it will be 0 always, provided we don't go wrong in calculating. So we see that the discriminant, when you have a quadratic equation, which is a perfect square, the value of d will be 0. So when do you take d is equal to 0? When it's given that the equation has equal roots. When it is given that the equation has equal roots. Equal roots means d is equal to 0. Also, when it's given it's a perfect square, find k if the quadratic equation is a perfect square. Perfect square means a quadratic equation. If the quadratic equation is a perfect square, that means d is equal to 0. You can take any other example, children, like, see this one, square this, 9x square minus 9 is 27, 54x plus 49 is equal to 0, okay? So this one is a perfect square. So d will be equal to b square minus 54. B square minus 4 into a, 9 into c, 49. So you can just work this and see, you'll get 0. I don't have a calculator beside me. You can check that. That will be 0, children. Any quadratic equation, if it's a perfect square, the value of d will be 0. Yeah, now do this. So it's similar to what you did earlier, the previous one. What's the value of a? Oh, not capital A, small a. Small a, small a. Always use small letters, children. We use capital letters only if small letter A, B, C are in the equation already. Otherwise, you should not use capital A. Capital A, B, C you should not use. Only if you have A, B, C in the equation, the quadratic equation, then we use capital A, B, C. Otherwise, it's always small a, B, C. So A is equal to, children?
4 minus k.
4 minus k. B?
B is 2k plus
4k plus 4, ma'am.
Very good. C?
8k plus 1.
Sorry. Yeah. Now it's a perfect square. That means D is equal to 0. That means B square minus 4AC is equal to 0. Work this and tell me the value or values of K.
Ma'am.
Yes, children. Yes, Ritika.
Ma'am, yes, ma'am. Is the value 0 and 3?
0 and 3, yeah, for K.
Yes.
Okay. Let me check. Oh, yeah. Very good.
Yes, ma'am.
You're perfect. Very good, Ritika. What's the equation you got? Quadratic equation?
Ma'am, actually 9k square minus 27k is equal to 0. I got like that.
Yeah, correct. Correct.
So,
Very good.
yes, ma'am.
Yes, children. Since it's time, I think it's better we see the result, the answer. I'm not saying anything. I'm not explaining. You can just see the answer. ABC substituted. Then divide by 4 throughout. Same stuff, it's the same stuff everywhere. Okay. So here when we have 9k square minus 27k is equal to 0, take out 9k common. 9k common. So we get 9k square minus 27k is equal to 0. So we have 9k into k minus 3 is equal to 0. That means 9k is equal to 0. Which means k is equal to 0 by 9, which is 0, or k minus 3 is 0, which means k is equal to 3. Is that fine, children? Take a picture, all of you.
Taken, ma'am.
Yeah. I'll just see if there's a similar question so that you can try it as homework. No, right now I don't have. Okay. All of you took a screenshot, children, of that answer?
Yes, ma'am.
Yes, ma'am.
All right, children. All right, children. So that's it for today's session. Thank you so much. You may leave the call. Good night.
Thank you.
you.
Thank you, ma'am.
Thank you, ma'am.
Thank you. Good night.